Are there any updates on the production start of this graphene FFG?
Yes, the prototypes we're creating are handmade devices. Will logically lead humanity to the ability to convert surrounding energy into electric current. When this technology is fully developed, thoroughly understood, and supported politically, humanity will see these devices in every home.
We see hurricanes destroying wind farms, hail damaging solar panels. How important is it to prioritize such FFG devices for energy harvesting that are not affected by these climate factors?
These devices make it possible to achieve exactly what you mentioned earlier: autonomy, independence, and most importantly, safety. With each PowerCube, with each FFG, I immediately get electricity. Considering that global energy consumption is expected to double in the next 20 years.
Greetings, dear Holger. Our team is delighted to welcome you once again.
I'm also very pleased to contribute to the discussion on this topic today.
Yes, Holger, this isn't the first interview we've recorded together. We always look forward to the new opportunities to communicate with you. At the moment, our Kaleidoscope of Facts team is preparing to release the film, Fuel-Free Generators, Energy of a Free Society, in which we aim to emphasize how crucial it is for humanity to transition to fuel-free energy in the near future. Considering the growing number of climate disasters, this will become a vital solution for our society. In this regard, I would like to ask you a few questions.
I would be happy to answer them, as this is precisely the topic we're addressing. We have seen what happened again in Spain a week ago, in Valencia. Tens of thousands of people were left without electricity. Without energy, nothing in our society functions. And in the coming years and decades, this problem will only worsen. This means the global demand for energy is growing rapidly, and we can make a small contribution to addressing it.
Holger, how did the global energy lobby react to your desire to provide people with an inexhaustible source of clean energy?
I think at first, we were met with skepticism and even a bit of disdain. We chose a very provocative name, neutrino energy, which led people to say they want to capture neutrinos. This actually worked in our favor because such reactions, even when tinged with irony or disregard, brought attention to our topic. Then we conducted various demonstrations where our professors showcased different applications of the technology. This led people to speculate it must be a battery. The challenge is that electricity itself is invisible. Only its effects can be observed. Our technology operates within the microcosm, or quantum realm, which is beyond the direct perception of the human eye. For example, when a wind turbine spins and generates energy, it's relatively easy to understand. In our case, we work in the microcosm, and people can observe the effects. I've personally witnessed this during lab demonstrations and presentations. People would search under the tables for hidden cables, unable to comprehend how it worked. At a certain point, we transitioned from simply presenting and demonstrating to thoroughly explaining how our technology operates. This was a crucial step because the term neutrino continued to spark questions. People assumed we were trying to catch neutrinos. But neutrinos pass through everything, and that's precisely the strength of our technology. Since neutrinos pass through matter, we can operate in 3 dimensions. This means we can work in complete darkness, across multiple layers, and even underground, as neutrinos truly penetrate everything. I would like to quickly explain in just a few words what we do. We don't actually produce energy, but we convert it. We convert kinetic energy. I've mentioned the examples with the wind turbine. So let me return to it since this is a simple and illustrative example. A wind turbine rotates, and through this motion, kinetic energy is converted within the rotor coils, causing the movement of electrons. In our case, the movement also occurs. However, the challenge is that it cannot be seen with the naked eye. It's only visible under an electron microscope. Essentially, we have millions of tiny wind turbines, so to speak. We have something in motion. In our case, it's graphene, a two-dimensional derivative of carbon that oscillates in a wave-like manner, creating convex and concave areas, or microvibrations. Without these microvibrations, our technology wouldn't work. If we ask, why does this movement occur? The answer lies in the fact that many factors stimulate these oscillations. These factors include temperature differences, radiation, and neutrinos themselves, which give our technology its name. In other words, there is motion, and if something moves, energy must be present, because without energy, nothing moves. From the perspective of the second law of thermodynamics, and I want to emphasize this for all viewers, we operate in accordance with the laws of physics. Our technology is not a perpetual motion machine that generates more energy than it consumes. For something to appear at the output, there must always be an input from an external source. Something comes in, namely, a constant flow of energy enters from various forms of radiation and thermal energy, and the output is a flow of electrons, a steady current. This is due to the fact that this carbon derivative, graphene, has completely different fluctuations than silicon. It is important to note that at the same temperature, according to the second law of thermodynamics, heat alone cannot perform work. This holds true if we assume that materials oscillate identically at the same temperature. However, we have a material that oscillates differently, even at the same temperature. Graphene and silicon behave entirely differently at the identical temperatures. This means that there is a gap between them, a difference. And between these two layers of silicon, what we call a graphene sandwich, our graphene moves up and down. There are excellent animations and electron microscope images on this topic where you can actually see it. Due to the convex and concave areas, impulses are created on the upper and lower layers, causing electrons to scatter. This phenomenon is what physicists refer to as skew scattering. Electrons scatter into the material through doping, slightly altering the material's properties and introducing a slight twist between the upper and lower layers. The electrons begin to flow in a single direction. In this way, we get a direct current. As I said earlier, this is entirely in accordance with the laws of physics and is fully explainable. It's just that it cannot be observed with the naked eye. Fortunately today, we have excellent animations to demonstrate and measure the results. So what advantage do we have now? Everyone is familiar with solar panels and understands that they convert something. But that's a chemical process, and we have a physical process. Our technology is significantly weaker. This means we generate much less energy per unit area. However, we have major advantage. Thanks to the third dimension, we can create multi-layer structures. As mentioned earlier, neutrinos pass through everything. This gives us the ability to work in the third dimension, compensating for the low output per unit area by increasing the overall surface area. We can think of this as a mathematical equation. Despite having less energy per square centimeter, there is much more energy per cubic centimeter. To explain it in simple terms, imagine a very thin, folded solar panel that interacts with invisible light. It is a foundation of our technology. The technical term for these layers is semiconductor wafers, where graphene is integrated into silicon plates, forming a graphene sandwich. This is the core of our technology. When we talk about the PowerCube, it is essentially a device that utilizes exactly the phenomenon I just described. Inside a PowerCube, for which excellent animations have already been created, there are a large number of these wafers. This provides us with a substantial physical surface area, enabling to generate a sufficient amount of energy despite its low yield per unit area. Our 5 kilowatt PowerCube is the first product we're launching on the market. You could say it's a kind of Big Mac for Neutrino, the first product to be introduced to the market. I think today we'll also talk a bit about this device. However, it was also important for me to summarize the technical aspects so that the listeners could gain a clear understanding of what we're working on.
Yes, thank you. You've somewhat anticipated the next question. Great. That was about the operating principle of this graphene-based FFG, the Neutrinovoltaic Powercube. Are there any updates on the production start of this graphene FFG?
Yes, it should be noted that when people envision constructing the entire device in a factory, that is indeed a misconception. Nowadays, electronic devices are assembled from purchasing components. This means that various components needed for such a device are already available in the market designed for these types of products. The only thing that is not currently sufficiently available in large quantities are the so-called graphene wafers. Producing this type of free-floating graphene between silicon is somewhat of a bottleneck. This is simply because manufacturing such wafers requires significant expenses, as they must be produced in a vacuum at a pressure of 10 to the minus 8th power. This requires clean environment. The process is highly sensitive, and the material used must be of a high purity. If graphene and lithium were to interlock, the graphene would be unable to oscillate freely between the lithium, which is essential for its function. This means that while we have mastered this process in the laboratory, many labs can do it as well. However, scaling it up for mass production necessitates machines capable of coding not just as square centimeters per second, but eventually as square meters per second. This is essentially what we're currently searching for, and we have found potential solutions in Southeast Asia. This means there are companies that cannot manufacture the PowerCube themselves, but can produce these wafers for us, as they are the foundation of the technology. To give an idea of the scale, we need approximately 1,500 square meters of wafer surface for a 5 kilowatt PowerCube to provide sufficient power. It is crucial to first ensure high quality and then to scale up production adequately. We're currently negotiating with suppliers because pricing is a significant factor. Producing these wafers in a lab setting is both labor-intensive and costly. The PowerCube is intended to be affordable in the market, and it is mass production and accumulated knowledge that will help achieve this. One can draw parallels with nearly any other technology. Initial prototypes and early experimental models are incredibly expensive due to manual fabrication. As understanding of these processes improve, costs will decrease significantly. I believe that by end of 2026, or perhaps in 2027, we will be able to enter true mass production. For me, mass production does not just mean a few hundred units, but rather tens of thousands or even hundreds of thousands of these cubes. And it doesn't mean we'll produce them ourselves. We couldn't do that at all. Instead, we'll work with industry producers who manufacture the components, which will then be assembled into the final cubes.
As far as we know, there was a plan to start the production of FFGs in Korea by the end of this year. But I think that target has not been met. Or have you already begun the production of these prototypes in Korea?
Yes, the prototypes we're creating are handmade devices. These devices are not yet as refined as the ones we see today. In other words, they still require further development. To illustrate, consider a fridge. On one side, there is a technology that enables it to cool, while on the other side, There is the aesthetically pleasing design that housewives are familiar with, whether it's chrome or white with all the features inside. We need to approach our PowerCubes in a similar way. The technology exists and functions well. It has been produced in a laboratory, albeit with significant effort. The partners we're working with in South Korea are very reliable, and the next step is to move towards what we call a small series production, which is currently being prepared for testing. However, I don't want to make any definitive statements today, as I will be traveling to South Korea later this year. During this trip, I'll assess everything on site and determine when we'll use the testing devices. We called it a field test, during which such devices will operate in home environments for 3 to 6 months. But at the same time, the development will definitely continue.
Yes, that would be the next question, Holger. Any updates on the field test? I think you've already addressed that. So, when you return from South Korea, you'll have new information on when the field test in Austria will finally begin.
Yes, that's absolutely correct. We're still facing challenges due to conflict in Ukraine. Over the past 2 years, many plans have been disrupted because we work as a part of an international team. Our collaborators include physicists and engineers from Russia, India, China, the United States, and other countries. Unfortunately, the political situation has severely impacted our scientific partnerships. It suddenly became impossible to work with highly skilled scientists and universities with whom we had previously collaborated. As a result, companies operating on a global scale have found themselves under significant strain. I can already anticipate the questions likely to arise in today's discussion, and I would like to address them. These types of obstacles in research and development undeniably affect companies and delay their time to market. On the other hand, I always remind my team, whenever this device reaches the market, we will know exactly how to produce it. We have completed the designs, prototypes, and samples. When this device is finally launched, it would deliver tangible benefits to society. I was born and raised in Germany. My father was a nuclear physicist, and my grandfather was an engineer. This background has instilled in us a clear understanding of the minimum quality standards that such devices must meet and adhere to. These devices are expected to function reliably for at least 15 to 20 years. That's why it's better to take the extra time for thorough testing and ensure quality than to rush a product to market that falls short of expectations. Patience pays off. Of course, this approach can invite criticism, but we know exactly how the process works. Investing additional time in testing now allows us to deliver something truly outstanding later. This demonstrates to me that competitors and representatives of other technologies truly understand the potential of this type of technology. Naturally, neutrino energy won't dominate the global energy market in just a few years. However, I firmly believe that recognizing the existence of technologies today capable of harvesting ambient energy, so-called energy harvesters, opens the door to transformative possibilities. Over the next 10, 20, or 30 years, these technologies could enable most electronic devices currently rely on fossil fuels to become entirely autonomous and disconnected from the grid. This transformation is a gradual process that starts small, with the first generation of devices paving the way. I believe that in 15 or 20 years, when this technology is fully developed, thoroughly understood, and supported politically, humanity will see these devices in every home, because it simply makes sense. This approach makes logical sense. Energy should be provided exactly where it is needed, rather than being produced centrally, transported, and converted, often with alternating current and significant losses. Energy should be readily available anytime and anywhere it is required. And for that, I need a raw material resource. This means that, on one hand, I need a functional tool. I've mentioned this before. The functional tool is a converter, what we call Wandler in German. On the other hand, I also need a raw material resource. When it comes to fossil fuels, the raw materials are wood, oil, coal, or gas. In our case, the raw materials are ambient radiation and temperature. But this too is a raw resource. It's just available in a different form. We don't need to dig into soil to extract it. It comes from above. The most logical aspect of the system is that we're simply using a different kind of resource, made accessible by human evolution. Neanderthals and early humans began using fire to burn wood. Over time, the process evolved to include coal and gas, burned with increasing efficiency. But ultimately, these are chemical processes that release not only carbon dioxide, but also nitrogen oxides. While carbon dioxide is a critical topic for me, it's not the main focus. A critical aspect of combustion for me is the emission of nitrogen oxides and exhaust gases, which are undeniably harmful. As for carbon dioxide, I agree with scientists because there are numerous models attempting to determine whether climate change is caused by human activity or not. However, when it comes to nitrogen oxides and exhaust gases, the evidence is much more apparent. Anyone can sense it when a car passes by and you inhale those fumes. I am convinced that humanity will make tremendous progress if it can eliminate its dependence on fire for energy production. Understanding that energy surrounds us and the space around us, and can be harnessed using harvesting technologies such as extracting energy from the environment, including neutrinos, confirms its compliance with the second law of thermodynamics and other physical laws. We convert measurable energy into measurable electrical current, which is crucial for dispelling any doubts from critics. This is a key point. By studying the operating principles and blueprints, one can undoubtedly criticize our devices at the initial stage of development. It is likely that they will continue to be refined over several months or even years. Once you understand the operating principle, it becomes clear that there is no turning back for this technology. It's based on the logic of the radiation that surrounds us, and it is evident that this resource can meet the global energy demands. Of course, I need equipment to convert these resources into energy. In the future, the industry will take this on at a larger scale. We're merely pioneers, among the first to do this. After all, the first car wasn't a mass-produced model either, and it wasn't yet the Golf or Mercedes we know today. It was just the first demonstration model, the first attempt to show how it works. It's important to understand the evolution of technology and how it will develop in the coming years. I can already see our engineers and technicians performing calculations and creating models. A major advantage is that we can use supercomputers and artificial intelligence for these tasks. This makes it possible to assert this type of energy, regardless of whether it's our device or another with even greater efficiency, will logically lead humanity to the ability to convert surrounding energy into electric current. This is a solution to today's problems that arose within the previous system. However, this is not a task that can be solved in 3 or 5 years. That is completely unrealistic. Considering the terawatts energy consumed by the Earth and the electrical devices developed over the decades or even centuries, including energy grids, it is clear that this is a project for several decades. We're offering a solution. Our goal is not to manufacture products for the entire world, but to provide a solution that will be adopted by industry and supported by policy to create long-term opportunities that will serve humanity for the next 10, 20, 30, or even 50 years.
Yes, thank you, Holger. You've already mentioned that. Now, I'd like to share with our viewers. We've been in touch for a long time. We both have constantly tried to change something, but have inevitably faced certain limitations. For a long time, we couldn't even communicate. I know a little about what happened there, and I want our viewers to understand that it's not so simple to introduce this technology to people. What difficulties did you constantly face in the past?
There were several difficulties. In the beginning, we were ridiculed. We didn't have a fully developed PowerCube. We started with a small lab sample of the technology, just a few centimeters in size. These samples demonstrated certain results, and I, being full of enthusiasm at that time, eagerly shared them, calculating through theory and mathematics that it would be enough. After that, I found my first company and started speaking publicly quite early on. At that time, neutrinos were called ghost particles, considered massless and incapable of interaction. Space was thought to be empty. There was nothing around us, and indeed, we didn't see anything. And where there is nothing, nothing can come from it. This brings us back to the idea of a perpetual motion machine, where, as we know, it's impossible to extract more energy from closed system than was put into it. However, neutrinos helped us not because we catch them, but because they allow us to clearly determine the energy potential of the surrounding space. This means that if we have a particle with a mass that is very small and has an energy of 0.8 electron volts per particle, there are 60 billion of these particles. We can determine the energy per square centimeter of the surrounding environment. And this is actually only solar neutrinos. Other particles are added to this. In other words, this is primarily a physical and technical determination of the energy of the surrounding environment. Because many people ask, where does the energy come from? The energy comes from the spectrum of radiation around us. This has been established and confirmed by scientific research. The second challenging aspect was the creation of the converter. The first converter was just a small piece of foil. This led to the claim that we catch neutrinos using foil. Then some professors came forward, claiming that neutrinos cannot be captured, that it's very difficult and requires large water reservoirs. But there were indeed people who tried to capture neutrinos in large experiments like Super Kamiokande. However, this is not what we do. We give neutrinos an impulse, like a small ping pong ball giving a slight push to a bowling pin. The exact term for this is nuclear scattering. After that, the neutrino simply continues on its path, which is completely normal. But the name neutrino itself sparks criticism. I remember when we first started talking about neutrino energy, and 2 or 3 professors were brought in who quite seriously stated that neutrinos cannot be captured. And if someone uses some kind of metal, it's impossible. That doesn't work. No one asked, what's exactly happening with this metal? Why does it work? What system is behind it? We truly face challenges trying to get out of this absurd situation. Fortunately, the Nobel Prize in Physics was later awarded, and the mass properties of neutrinos became recognized as significant. I want to express my gratitude to the fundamental physicists who, although not directly connected to our technology, nonetheless proved the existence of these properties. That was crucial because everything must comply with the second law of thermodynamics. We need energy, and its existence is confirmed by the postulate and precise definition of neutrinos. We know that this form of energy and its quantity truly exist. The next step was a study of the so-called non-standard model interactions. The first universities began to prove that neutrinos do indeed interact with mass. And this was important because, in this way, we at least gained the right to use the term neutrino. I mean, neutrino is a trademark. Let's imagine coffee. If I say that coffee is water, Of course, I want there to be at least a little bit of coffee in my coffee. Yes, there is a lot of water, and a chemist might say, there's too much H2O in your coffee, but it's still called coffee. This is a good example to understand why our energy is called neutrino energy, because neutrinos do interact, and part of the energy obtained through nuclear scattering comes from neutrinos. This is very important. At the time, when we started working on this topic, we were bombarded with denunciations, many of which were absurd. Numerous of lawsuits were filed, and our case became something of an entertainment for the judicial system. Now, I talk about it with a smile because all of the cases were closed without exception. The prosecution not only dismissed them, but also based their decisions on our explanations, acknowledging that now they understood the situation. What we're doing is absolutely legal. We're trying to develop this technology. We have the scientific foundation, patents, trademarks, and we have invested capital. Primarily, this was my personal and family capital, and at some point, we began raising funds through private placements. We asked people who understood our idea to support us because this is really expensive. However, shortly after this, rumors started circulating that we were allegedly involved in financial operations and criminal lawsuits began to be filed against us. Then for years, we had to deal with criminal cases. After that, international work began. The charges were dropped, and major partners and investors with large capital came in. But the problems didn't stop there. Then we were accused of money laundering, which led to funds being frozen or delayed due to our collaboration with scientists from countries that aren't considered part of the right circle. And we had to overcome all these difficulties while continuing our research and development. Even today, at the beginning of November, I can say that a significant portion of our funds is still frozen here in the Western countries because we worked for a long time with Eastern European physicists, engineers, and institutes in Russia, who, by the way, are the leaders in the development of carbon derivatives. It was a time when all of Western Europe was working with Russia. I would say that all of Germany was buying oil and gas from Russia. And then suddenly, the war broke out. Many companies, including ours, suffered greatly. If you look in the press, I also published explanations stating that this is not about hundreds of thousands or millions. We're talking about billions of euros that are artificially being withheld from our group of companies, even though they belong to us, are on our balance sheets, and were earned through licensees and shares. Despite this, we continue to work and move forward under difficult conditions, and we will continue. But today, we're at a stage where it is no longer possible to stop this. The public has understood how this technology works. Even if, let's say, they attempt to eliminate or destroy us as a company, this knowledge already belongs to the world. This achievement we have gifted to the world. With this knowledge, the world can implement this technology. Whether we build PowerCube or someone else will do it in the future, because the blueprints are available and there is a clear understanding of the process. We have, of course, published patents. The advantage of patents, as many think, is in its protection. But the downside of patent is that people can copy it. And of course, not everyone who copies will pay royalties for the patents. We understand that our knowledge is already serving as a foundation for others to work with. And that's exactly why patents exist. To disclose this knowledge and encourage others to make new discoveries based on it. This is the purpose of patents, to inspire people and protect knowledge. A patent, of course, is always relevant only at the moment the knowledge is acquired. And with the constant expansion of patents, this knowledge will evolve. Thus, anyone who is interested today can thoroughly study the patent descriptions. If a person is clever enough, they will be able to make use of our knowledge we have developed over decades with great effort, love, and significant investment. However, we accept this because we believe it is our duty to society to share this knowledge.
Thank you for all the information. This will allow people to understand the challenges faced by such valuable technologies. Holger, I also think it's important to discuss your perspective on the role of technologies like FFG, not just neutrinovoltaics, but all energy harvesting devices that use invisible radiation in solving climate problems and supporting affected countries. Earlier, you mentioned Spain. How important is this technology for humanity?
In my opinion, in Central Europe and the USA, we live within a highly developed and complex energy system, which has become the norm for most people. Every home is equipped with numerous devices, such as televisions and refrigerators. All of this developed gradually. However, there are still many countries in the world, especially in Africa, where people still face serious energy supply problems. Many people have no access to electricity at all, which automatically deprives them of opportunities for education and economic growth. This is a huge problem. Considering that global energy consumption is expected to double in the next 20 years, it is crucial to develop new technologies that can meet these needs. Clearly, a few devices like FFGs, fuel-free generators, or PowerCubes will not solve the problem, even if there are millions of them. It's about transferring knowledge to humanity so that we're not limited to creating devices with power of 5 kilowatts, but instead develop of smaller sizes. These could be integrated into any electronic device, including mobile phones. For this, integrated electronics will be needed to convert energy, such as the heat from the hand, ambient heat, or available radiation. If I no longer have to charge this small electronic device, it's already an energy saving because I'm no longer drawing power from the grid, which was previously generated using fossil fuels. If we scale this up to millions or even billions of devices, each consuming between 1 and 10 watts, this could amount to terawatts of energy that can be saved. Thus, if devices begin harvesting energy from the surrounding environment, they no longer need to be charged from the grid. There are various models for how many years or decades this process will take. But personally, I believe that in 30 to 40 years, we'll both be sitting somewhere in rocking chairs. However, I would say that the entire energy transformation process will take at least 30 to 50 years. But in 30 to 50 years, society will likely be entirely based on so-called harvesting technologies because everything else will no longer be necessary. We understand that there is enough energy. It just requires a little more refinement of the technology and making it attractive to people. We should start with the first devices and prove people that it works. Politics should facilitate the integration of these technologies into practice. And then based on logic, I think everything will develop gradually. After all, the main advantage of this resource is that it doesn't need to be extracted. It doesn't require significant costs. It doesn't produce pollutants when burned. It's free. It's always available. I don't like the term free energy because the concept of free is also defined by the second law of thermodynamics. On the other hand, the concept of free energy is often associated with sources like solar energy or wind, which can also be considered as free energy if viewed from that perspective. But to use it, devices are needed. Nevertheless, such energy is much more accessible than anything we know, and therefore cheaper. And if I don't need to extract raw materials like oil and gas, then naturally, I shouldn't have to pay for them. However, electricity will not be free, although its price will decrease if technologies like PowerCube are used. Nevertheless, governments will likely impose a tax on the use of ambient energy. pay a tax, even if you take energy from the air. This is truly a business model that cannot be ignored. Governments around the world are funded by energy. Energy is a market. Energy is a business. One cannot be so naive as to think that humanity will simply receive a device as a gift. These devices will certainly be taxed someday. They may even have a meter installed, and someone will say, "This is how much energy you have received from the environment." But it will still be more beneficial than burning fossil resources and emitting pollutants. When people understand this, then this technology will have a chance. That's why the term free energy is important. Many hope that electricity will be free. No, it would just have a much lower cost. And its impact on society, nature, and environment will be much smaller. All I can say is that these processes need to be stated as soon as possible.
Yes, Holger. Let's move on to the last question. We were just talking about climate issues. I want to ask you this question again, so that our viewers truly realize how important this is in the context of the current climate problems that we see around the world. There are hurricanes, tornadoes, typhoons, earthquakes, hail. We see hurricanes destroying wind farms, hail damaging solar panels. How important is it to prioritize such FFG devices for energy harvesting that are not affected by these climate factors?
Absolutely right. Without electricity, nothing works in our society. Let's put it this way. If the refrigerator doesn't work for 2 days, everything inside of it will be thrown away. That's the reality. Nowadays, in our society, all communications relies on energy. Nothing functions without it. These devices make it possible to achieve exactly what you mentioned earlier: autonomy, independence, and most importantly, safety. If we calculate, the capacity of these devices might not be sufficient, then I would say 5 kilowatt and 100,000 power cubes is not much. But if you take 5 kilowatt and multiply it by 200,000 power cubes, just a straightforward mathematical calculation, that gives you 1,000 megawatts. 1,000 megawatts is an output of an average nuclear reactor. On average, a nuclear reactor generates around 1,000 megawatts. However, a nuclear reactor first needs to be built. That's no simple task. It requires planning, construction, and at least 10 years to complete. Then it will likely cost $20 billion. On top of that, additional cables and power lines would need to be laid to deliver the electricity to consumers. Then I would need to step down the voltage of the current, these 360,000 volts of alternating current that I transport, to make it suitable for consumption. And here, I face exactly the risks that you mentioned. It could be not only a nuclear power plant, but also a coal, gas, or any other type. Such power plants and transmission lines can be damaged due to environmental impacts or as a result of wars, as we're currently seeing in Ukraine. In other words, all critical infrastructure becomes vulnerable to attacks. Objects like transformers and power plants get damaged, causing power outages for people. However, if we create a network of many small energy sources, as we have already calculated, even if one or another source fails, the system itself remains stable. The electricity that I don't use can theoretically be fed back into the grid, and if there is a grid, it would be foolish not to do that. But overall, such a system provides much greater stability. This means that if we look at decentralized, autonomous energy supply from a mathematical perspective, we can see that this approach can fully compensate for the many shortcomings of the current system. However, this takes time. It's not just a matter of saying that everything will be ready in 2 years. It's probably worth starting with the countries where there is no electricity supply at all. Instead of upgrading old centralized power supply systems, preference should be given to decentralized autonomous energy suppliers. This is the easiest way to do, especially in areas where an upgrade is needed. With each PowerCube, with each FFG, I immediately get electricity. If I have 100 or 1,000 households, I simply install 100 or 1,000 devices, and people immediately start receiving electricity. If my power plant breaks down, I first need to build a new plant and lay new lines to deliver electricity to people. It's truly much simpler in terms of dynamics, flexibility, and opportunities, especially in countries where the population lives far apart. A good example is Africa. Most African countries didn't have a traditional telephone network. Laying cables for thousands of kilometers through jungles simply didn't make sense. However, today, these people use mobile phones because evolutionarily, they kind of skipped that step. They didn't lay cables and went straight to mobile communication. People, no matter where they are in Africa, I've seen it myself, suddenly started using mobile telephones. The same thing is happening with electricity now. So even if I don't have an extensive system, cables, and power plants, I can still provide people with a sufficient amount of energy in a very short time using devices of this type.
Thank you, Holger, for your time and responses. We are glad to have such a wonderful partner with whom we can always communicate and who constantly shares new information with us.
Thank you very much. It's a great pleasure for me. It's very important that I can reach the majority of people through you. This is clearly evident from the number of views. But the main thing, in my opinion, is that humanity begins to understand. Through understanding the technology, I can directly reach out to my industrial partners and engage them so they understand the idea. Over time, the need will create demand, which will lead to the creation of the device. We can show how it works and become a role model, but we cannot cover the world's energy demand with just our PowerCubes. We don't have the resources to build 10 gigafactories, so we need to attract powerful industrial partners, as well as politicians who can promote this mindset in the countries and build future models based on it. When we reach the point where we train young specialists, bring knowledge to people who will then pass it on and further develop it, this will be our great achievement. Then I will be able to say that I fulfilled my task, that nearly 17 years of work, effort, labor, love, investment have been justified. Together with you, our partners who help spread this knowledge, the process has already begun and is gaining momentum in other countries. I think it would take another 3 to 5 years before this technology is widely adopted. But its implementation will begin soon. And for this, I want to thank our amazing partners, scientists, like-minded individuals, and those who have stayed in the background, but have been helping us all this time. Everyone has made a valuable contribution. Once again, I express my deep gratitude for this opportunity.
Thank you, Holger.
You're welcome.